So this is an example problem for component method. So an easy problem. So EQ travels 3 meters west, 4 meters north, and 6 meters east. So what is his resultant displacement and what is the total distance he travels? Actually, the second question can be answered by just looking at the given. Since you're looking for the total distance, you don't consider here the direction. You just add 3 meters plus 4 meters plus 6 meters, and that gives you 13 meters. So 13 meters is the total distance he travels. While for the displacement, the resultant displacement, you need to use the component method in solving this kind of problem. Or if you want, you can also do graphical way. But for more accurate results, it's better to use the component method. We need to identify first the given. So the given in the problem are this. So D1 is 3 meters west, D2 is 4 meters north, and then 6 meters east. If we change the geographical directions into angles, west is the same as angle is 180 degrees, north is 90 degrees, and east is 0 degree from the positive x-axis. Have the sketch to determine the location of the resultant vector. Okay, so D1 is going west, D2 is going north, and then D3 is going east. Okay, so take note, resultant vector is drawn from the tail of the first vector, which is D1, to the head of the last vector, which is D3. So this is the resultant vector. So what is the value of the resultant vector and as well as the direction? Because vector should have magnitude and direction. Okay, the next step that we need to find is the x and the y components of vectors d1, d2, and d3. So recalling the formula for dx, so that is d cosine theta, and then dy is d sine theta. So if this is d1, so that is d1 sine theta 1, d2, d2 sine theta 2, and so on. Same case for dx, so d1x, that is d1 cosine theta 1, d2x is d2 cosine theta 2, and so on. Okay, since we have d1, d2, and d3, so we are expecting 3 components of x and 3 components of y. Okay, solving for dx, so d1x is 3 meter cosine 180 degree, 2x is 4 meter cosine 90 degree, and then d3x is 6 meters cosine 0 degree. Same case for dy, so d1y is 3 meters sine 180 degree, d2y is 4 meters sine 90 degree, and d3y is 6 meters times sine 0 degree. Okay, recalling some functions, sine cosine, sine 0 is 0, cosine 0 is 1, cosine 90 is 0, sine 90 is 1. Cosine 180 is negative 1 and sine 180 is 0. And then we evaluate this. Cosine 180 is negative 1. Cosine 90 is 0. Cosine 0 is 1. Same case, sine 180 is 0. Sine 90 is 1. And sine 0 is 0. So you notice that there's no x component for d2 and there's no y component for d1 and d3. So multiplying this, so 3 meter times negative 1 is negative 3 meter. This is 0 for d2, and then this is 6 meter. Okay, and then for d1y, so this is 0, d2y is 4, and then d3y is 0. So the next step now is to get the sum of components along y as well as the sum of components along x. So if you get the sum, that is negative 3, 0, 6, that gives you 3. Okay, so that is the sum of the resultant along x Okay, and then this is along y. So that gives you 0 plus 4 plus 0, that is 4 meters. So drx is 3 meters while dry is 4 meters. Okay, just recalling, drx is d1x plus d2x plus d3x, that is negative 3 plus 0 plus 6, and dry is d1y plus d2y plus d3y, that is 0 plus 4 plus 0. So if you're going to get the sum, drx is 3 and dry is 4. Okay, the next step now is to solve for the magnitude of dr. So using Pythagorean theorem, the square root of drx squared plus dry squared, that gives you the magnitude of the resultant vector. The resultant vector, so square root of 3m squared plus 4m squared, so that gives you 9 meters squared plus 16 meters squared. So 9 plus 16 is 25. So the square root of 25 is 5. Okay, so that gives you 5 meters. Okay, same case, recalling to get the angle theta, so that is the inverse tan of dry divided by drx is equal to inverse tan 4 meter over 3 meter. So this is equivalent to 1.33. So inverse tan is, okay, so the angle is 53.1 degree. The magnitude of the resultant vector is 5 meters. Okay, so this 53.1 is in which quadrant? So if you check the value for drx and dry, they are both positive. So meaning to say, this is along the first quadrant. So if we write the final answer for the resultant vector, the final answer is this. So the resultant displacement is written as 5 meters 53.1 degrees north of east. So that's how you solve this problem using component method. Okay, thank you for watching.